This one again is refers back to exactly what we've been doing the entire year on our transformations. So the first thing is we did this with exponentials, and now we're doing it with logarithmic graphs. Okay, so a logarithmic graph looks like this, correct? Okay, in which that coordinate there is 1 and 0, right? Now, if I take that graph and I have to translate it or move it, log. Okay, so the base doesn't really matter about anything. Okay, what happens to this graph? What do you have? Left 4, down 5. Okay, so by moving it left 4, this guy then becomes right there, right? So this will be, this equation of this will be x is equal to minus 4. And then this coordinate here is going to go left 4 to here, and then it has to go down 5 to right here, in which it's going to up and cross this axis somewhere. Okay, so now, first order of business is the domain and the range. What's the domain for this graph? X is greater than negative 4. Starts here, gets as close to that line as it can, and then goes to the right. What's the range for this graph? Y is an element of all reals. The x-intercept on this graph is what? How did you get negative 3?
Oh. I was down.
Yeah, negative.
Sorry.
What do you think?
Negative 3.
You think it's negative 3? The x-intercept?
Would be 1 minus 4.
For me?
1 minus 4.
Yeah, but that coordinate also went down 5, correct? Right? So how do I get it? Well, I'm going to show you, you could graph it, okay? You could graph it. But to get the x-intercept, that's when y is equal to 0, correct? So I've got this, the log of x plus 4 minus 5 to the base 4. Now here's the meat and potatoes of what we've got to do. Okay, I need to solve for x here. So I mentioned this morning, and I'm going to mention it again. This is the most crucial thing that you're going to need to be able to do is convert from a logarithm to an exponential, and an exponential to a logarithm. All right, so I'm going to solve this by moving the 5 over to here. Now I want to convert this. Okay, to an exponential equation. So to do that, I go 4 to the 5th is equal to x plus 4. Okay, take this base, move it up to this side. That becomes my exponent. And then it's equal to whatever it is over here. So I subtract it. So x is equal to 4 to the 5th minus 4. Now realistically, you could probably leave it as that. If you were doing this in a non-calculator section on the exam, I would leave it like that. If you're doing this on the calculator section of the exam, I would find out what the actual numerical value is. All right? And then I would solve it. So what is this? 4 to the 5th subtract 4.
1020.
1020. 4 to the 5th is 1024. Yeah? Okay, good enough. So we have 1020. What is the y-intercept in this equation? You see it? It's hard to see from my graph because I drew it poorly. But what is the y-intercept? This also brings about another unique property that we need to learn, and we're going to go through right away here. And that is this. Y is equal to the log of 0 plus 4, the base 4, subtract 5, correct? I have to put 0 in for x to find out what the y-intercept is, correct? So now, I'm left with the log of 4 to the base 4, subtract 5. Anybody know what the log of 4 to the base 4 is? Yes. That was one of those rules that we looked at last week. The log of any number to the same base is actually equal to 1. Okay, and that's another thing that we need to remember. And that, I wouldn't say it's on your formula sheet, but it's possible that it would be. So then the answer then is your y-intercept is minus 4. So to redraw this equation over here, and draw this graph, and do this again. So that's here, here. So my graph is going to look more like this now. Down here. Something like that, a little curve. Because this has to go to 1020. Right? That's where it crosses it. And then this y-intercept here is -4. Okay? What's the equation of the asymptote here? I wrote it up there. What is the equation of the asymptote? X equals -4. Okay? So this is 8.2. I don't want to go through any more than that. Alright? Because it's redundant right now with the same thing that you did for exponential functions, the same thing that you did for trigonometric functions, the same thing you did for polynomial functions, and soon it'll be the same thing that you do with rational functions. So it's all the same. Okay, your shifts, again, H and K are left and right and up and down. A changes how steep or how quickly it gets up, and you multiply all the y values by A. You multiply all the x values by 1 over b, whatever it is. So your standard equation, your general equation, y equals a log, I'll put this as base c, so I've got b x minus c added d. Right? So C and D, or H and K, C is right, left, up, down, multiply the y values, multiply the x values by 1 would be. Same thing. Okay? Anybody have questions about that? Because I'm going to go to the new stuff, and the new stuff is what we have to get a grasp of. Okay, that's just basically to skim over it, not skip it, but skim over it. So do a few of those questions to make sure you know how the transformations work. Just use your calculator to do it. Okay? All right. Let's look at 275. This is what we have to do. All right. Again, all of these rules. So if you take out your formula sheet, you're going to see that the rules are on the formula sheet for the most part. I'm going to add some that aren't on the formula sheet, but the 3 basic ones are on the formula sheet. I gave them to you the other day, so let's have a look at it again. All right. These are all based on exponent rules. Okay, so I can show you all of the derivation behind it, but we don't need to know it. We need to know how to use it, not how to get to it. Okay, so here's what the first rule is. It's called the product rule. When I have, and I suggest you use brackets for this. They don't use them, but I'm going to suggest that you do. Because to me it looks wrong. To me, if I read this, it would be the log of m to the base b times n if I didn't have the brackets. When you multiply in here, that is the same as saying the log of m to the base b plus the log of n to the base b. Again, that is not a multiplication. That is a function. Okay? This does something. The log does something. It's not the log of multiplying. It's very similar to trig. Trig, when we have the sign of alpha plus beta, we do not multiply the sign through there. It's the sign of the alpha plus the beta. This is the log of m times n. The second rule, log of m over n. Again, if it is very similar to the exponent rules, what do you suppose happens here? You subtract them. When you have a to the x over a to the y, you subtract the exponents. So it's very similar. Okay, when you're dividing, it's over that. This one's a little bit different, but still fairly easy. When you have a product, and I mentioned this to you last week, when you have an exponent within the logarithms, this goes to the front of it. So it becomes n log m to the base b. Okay, so it moves it to the front. Other rules that we need to know. What was this one? I said it earlier today. Log of b to the base b equals 1. Okay? No. Remember, we're trying to prepare. And the formula sheet is all you're getting for the exam, so we don't want to do anything more than that, so we're used to it, right? Okay? Alright, so what is the point of this? The point of this is when we do questions, our objective will be, depending on what we're doing, this allows us to work in different bases, number one. So if I had 3 to the x is equal to 7, and I asked you to solve for this, okay? Then you can change the base, because right now I can't get the same base. So what I would do is I would take the log of both sides here, all right? So I take the log of this side, log of 3 to the x is equal to the log of 7. Now I've changed the base. What did I change the base to? To 10, that's right. If it's not written in here, I've changed it to base 10, which is what your calculator works in. Now I use these rules. I need to get x, so I move x to the front. Okay, don't write this down yet, because we're gonna go through all of this, right? So now it's x log 3 is equal to log of 7. Now how do I get x by itself? So what have I done? I've taken an exponential function in which I can't get the same base. I converted it by using logarithms to change it to the same base so that I could use my calculator and I solve for it. So what is the x value up there? Well, it's the same as the log of 7 divided by the log of 3. And all of that has to do with my logarithm rules. Most specifically is this one, because I took the x and put it to the front. So I'm going to use these rules to solve questions. All right, now I'm going to give you the ultimate question here, the exam style question, so that you have an understanding as to how this is going to look. Let me do this. In fact, I'm going to do this different. I'm going to, again, this is guaranteed on the first 11 questions on the exam. So, if it's not the first question, because they're ones. So I'm gonna give you, this one's quite complicated. Okay, but I'm gonna start it for you. I'm gonna give you an idea as to what we're looking at, and then we're gonna go back and we'll do the examples for you. Just a second, I want to make sure. Maybe it's too complicated. No. 8.4 deals with this more. Okay, so an example of a question, this is an exam question, 6. Don't write this down either. It's not going to make any sense to you right now. So there's the question. I want to find out what x is. So in the current form that it's in, I can't do it, can't find it out. So this is difficult for us to deal with. This is actually, that's about as hard as you're going to get for a question like this. Okay? So what do? Well, the only way I can get the x out of being an exponent is if I change the bases so that they're the same. So that's what I would have to do. So what I would do is I take the log of this side and the log of this side. Okay? Now that becomes this. Alright? So now using my first rule, I need to adjust this. So my first rule is log of 6 plus the log of 5 to the 3x out of 2, right? Is equal to the log of 9 to 2 minus x. Okay? I still have that exponent being my variable. I don't want that. So now at this point I need to use one of my log rules to not have it as the variable, or as to have it as the exponent, I mean. So what do? That comes in front here. That comes in front over here. So now I'm no longer dealing with an exponent being a variable. Okay? Extremely tough question to do this algebraically. So what would you do? Well, what I would do is and that's why it's in the calculator section, is I would graph both sides and find your intersection. But to carry this on would be very tough. Log 6 plus, that's 3x added 2, log 5 equals 2 minus x, log 9. Okay, so I just moved them all to the front, and then it's just a whole lot of algebra. Okay, so I would multiply that through, I'd get the x's to one side, I would divide, and it would be just a mess of work. Okay, which is something we are going to work too, but not today. But this is the reason that we are learning the rules today, the very basic rules. Because I need to be able to take a question that started with an exponent, in which the exponent was the variable, and I need to be able to manipulate it so that I can get it, so that I can solve for it as not being the variable, as not being the exponent. So that's what we worked in. So look on page 275 then, and all they're asking you in this section is to practice using your rules. So here's what I have. It has the log of x squared y over 4z. X cubed. X cubed y. Alright. So now what it's doing is it says, okay, let's use this and let's write it in terms of an expanded form, right? It says expand each expression using the laws of logs. So that's what we're practicing. Okay, so the multiplying means I do what with the logs? For multiplying. Like on the top here, what do I do with it? Product, add them, and then I'm going to do what with the bottom? Subtract. Right? So here's how it looks. I'm going to have the log of x cubed base 4 plus log of y base 4 minus the log of 4 base 4 minus the log of z base 4. Okay? So if it's on top of the fraction, I'm adding it. If it's on the bottom of the fraction, I'm subtracting it. So now I'm going to continue with my log rules just to simplify it a little bit, because I don't want, at this point, I don't want the exponent to be there. So what do I do with this exponent here? Move it to the front. So here's what I'm going to end up with. 3 log x base 4 plus log y base 4 minus, very good, 1 minus log z base 4. And there's your expanded form. Okay? And again, the purpose of this is going to be to convert it back. All right? Expand it, collect your terms, and then convert it back into exponential so we can solve. So let's look at the next question. Any problems with this? Again, it's just the rules. All right, so we're going to follow through. So now it gets a little more complicated if you look at B, because you have this, the log of square root now.
XY cubed.
XY cubed, thanks. Base 5?
Yeah.
Perfect, okay. So before I do anything, all right, I don't want to work with roots. So how do I change the root so that it's an exponent to a half? So here's what I have. Log xy cubed to the 1/2 to the base 5 equals. Okay? Sure. I could do that. I would do that right away too. I like that actually, right? I'm going to do it like this though, okay? So far so good? Okay? So now, because I have a product in here, right? What am I going to do with it? Add them. So I've got this 1/2 log x to the base 5 plus 1/2 log y cubed to the base 5. We okay so far? What's the last thing I want to do? Get rid of that other exponent, move it to the front, and then multiply it by that. So here's my final solution, 1/2 log x base 5 plus 3/2 log y base 5. Okay? So the order in which I do this didn't matter. I could have moved it there, or I could have done it down here, whatever. I could have multiplied this and that through the brackets. So I could have had log x to the 1/2 y to the 3/2. And then I would have still done this exact same stuff here. Okay, so it's up to you. It doesn't matter. All right, let's try this last one now.
So for these questions, is that all you have to do?
That's all you're doing right now. Yeah, that's all you're doing right now. So the log 100 cube root of x to the 4th over y squared equals. Okay? I could, for sure. For sure, I probably would, yeah. Okay? I could do this in one step. I could do it in 2 steps. Depends on how we are. I know that that's going to be add, correct? And then it's going to subtract the bottom, right? So let's just work through it that way. So I have log 100 plus the log of x to the y. What is it? You're right. Somebody said it. 4/3, right? This is to the 1/3, correct? So it's x to the 4th to the 1/3. So that means it's 4/3. I just skipped a step there. Okay? Minus the log of y squared. So now let's just simplify the last bit here. The log of 100. Can I simplify that? What do you got? Stop. You can't use a calculator. Non-calculator section.
It's log to the base 10, so the 2.
Okay. So I'm going to just write it over here. What is 100? 100 is 10 squared, correct? Right? So now, that goes there. What's the log of 10 to the base 10? 1. So this is actually 2. Right? And then I have, the rest is just moving now. 4/3 log x minus 2 log y. That's a good catch there. All right, make sure that you understand if you see 100, 1,000, 10,000, whatever it may be, when you have no base, it's log 10, so you're probably going to simplify it. Okay? And then the second part of this is to work it backwards. So right now I'm expanding, all right? Because there's going to be a way in which we have to solve questions by expanding, exponential questions. And now I'm going to work backwards. So let's see how well you work backwards. This is actually, to me, a little bit simpler. So I have the log of x cubed to the base 2 minus 4 log x to the base 2
minus log x.
minus log root x to the base 2. All right. Want to see how to do this? Here's what I'm going to do. Log, and draw a line. If it's add, it goes on the top. If it's subtract, it goes on the bottom. And I'm going to place a bracket there. Okay? This one, positive, correct? So, x cubed goes here. On top of it. This is subtract right here. So what goes on the bottom? What do you have? X to the 4th. That's correct. Because that, whoop, I didn't do that. That goes up to there, right? If it's in front, now it moves back to the exponent. What is that one? Top or bottom? Bottom because it's subtract and it's what's the 1/2? X to the 1/2. Excellent. So there's what I have right there. Everybody okay with that? Fairly straightforward, right? Oh, I missed my base 2 in here. Base 2. And then I could simplify it. I don't know if they do. Let me just take a look. Yeah, they do. Okay? X to the 3rd. What do I do with these exponents here? I subtract them, right? So 3 subtract 4, negative 1, and then I got to subtract another half. So that's minus 3 over 2. So that's x minus 3 over 2. Like that. And if they wanted it in a positive exponent, how would I make that a positive exponent? That's right. Good job. There it is there. Okay? So that's working backwards. Now, why would I work backwards? Well, in this instance, if I'm working backwards and I had it equals to something, I would change it immediately to exponential and then I would solve it. If your x or your variable is in the logarithm, we put them all into one single logarithm and then we make it an exponential. So let's have a quick peek here. I'll find an exam question that looks just like that. Just so you have an idea.
a negative exponent like that.
You can leave it most times.
Can leave it unless they specify.
Yeah. I'm just gonna grab a different exam here and find you a question, just so you have an understanding. I like to show you the ends, like I said before. I like to show you the ends of the questions so that you have an idea as to what you're working to. I'm just hoping I have one in here. Is it graphing one? You know a good place for that phone is? Yeah, locker. Right in locker. Well, this exam did the same thing. It went exponential. Oh, here we go. Okay, so just give me an example of a question. This is an actual exam question. Does This is a non-calculator exam question as well. So, no calculator allowed. It's kind of tough to work it through like this, right? So here's what I'm going to do. When I get into this situation, when the logarithm, where the variable, is with a logarithm, I want to turn it into a single log and change it to exponential. So quickly to do that, log base 4, that's x squared over x plus 3 here. Right? Because it's subtract, bless you, because it's subtract, it goes that over that equals 1. Now I quickly change it into an exponential function, and then I can solve it. That to that exponent is equal to this. So I have x squared over x plus 3 is equal to 4 to the 1. Now I no longer have logs, and I can solve the question. Times that up to there, x squared is equal to 4x at 12. Move it over, x squared minus 4x minus 12 is equal to 0. Okay, you don't need to write this down. This is, again, down the road, but I'm just showing you why we are doing the expansion of it today and why we're doing the simplification of it today, so that you can solve questions easier without the calculator. Alright, so then this one would be x minus 6, x plus 2, 0, x is equal to 6 and negative 2, you can't have a negative. And then if I put 6 in here and 6 in here, I'd have to check it to see if it still works, but it does. Alright? So, again, that's why we're doing both expanding and simplifying. Okay? Alright.
Why are you allowed to put the variable with the log in this one?